Hello, good morning, friends. Myself, Professor R.B. Vagasia, and I heartily welcome to all dear students in my YouTube channels. Last video lecture, we can discuss about that classification of the shift register. So we can classify that shift register in four different categories. First one is serial input, serial output register. Second one serial input, parallel output register. Third one parallel input, parallel output register. And last one is parallel input, serial output register. Now in this video lecture, we can discuss about that applications of shift registers. Application of shift register. So basically we can utilize the two types of the application of two types of the shift register. One that is known as a ring counter, and the second one that is known as a Johnson counter. And Johnson counter, it is also known as a twisted ring counter. So this is the two basic applications of the shift register. First one is ring counter, and the second one that is known as a Johnson counter. Now first one we can start about the ring counter. So dear students, now first one we can clear about that how that ring counter can be work. Otherwise, what is the logic of the ring counter? Suppose that we can designing the counter with the 4-bit storage. That means we can require the 4 flip-flops. So this is the clock signal. Now output of the first flip-flop, that is known as a Q0, then Q1, Q2 and Q3. Right? So this is the output of first flip-flop, output of second, third and fourth flip-flops. Now initially we can applying any clock signal. If we can designing with the positive level triggering, at the time we can applying the clock signal is 1. And now initially this is the 1, 0, 0. Now whenever the second clock pulse will become, this is the clock signal and this is the clock pulse. This is the first clock pulse. Now the second clock pulse. Each and every time we can applying the clock signal is 1 because of the we can designing with the positive level triggering. Now what happen whenever the second clock pulse will become, at the time the output of first flip flop that can be shifted to here. So this one that can be goes to here. This 0 can be shifted to here. This 0 can be shifted to here, and this 0, this is the last, again that can be given to the first, right? So this one is come to here. Now third clock pulse will be count. So again clock pulse is 1 because of each and every clock pulse we can applying the positive level triggering, right? So that 0 is shifted here, that 1 is shifted here, that 0 is again shifted here, and this one is again come to here. Now next clock pulse will become. So that 0 will become here, that 0 is come here, this 1 is come to here, and this 0 is again come to here, right? So this is the fourth clock pulse. This is the second clock pulse and first clock pulse, right? Now again next clock pulse will become. This is the fifth clock pulse. So again clock signal will be 1. So that 1, that 0 is shifted to here, that 0 is shifted to here, that 0 is shifted, and this one is shifted to here. So that means the first clock pulse and fifth clock pulse will be same in case of the ring counter. Again the next clock pulse will become at the time. Again that 1 is shifted to here, that 0 is shifted to here, that 0, and this 0 will become here. So second clock pulse and sixth clock pulse will be same. Now the remaining process will be same, right? So this is the logic of ring counter. So dear students, now we can designing the ring counter by using this logic. So first one we know about that we can designing the ring counter with the 4-bit storage. So we can require the 4 flip-flops, and dear students, we know about that in case of the D flip-flops, whenever our input D is 0, at the time output Q0 is also 0. When D is 1, at the time output Q0 is also 1. So whenever we can designing the application of the shift register, at the time we can utilize the D flip-flop, because of the when D is 0, at the time output is also 0. When D is 1, at the time output is also 1. Right? So now we can use the 4 D flip-flops. So this is the first. Now this is the second, third and fourth. Now, so we can applying the clock pulse to each and every flip-flops, right? And this is the positive level triggering, because of we can count the clock pulse is 1. So this is the clock signal. Now second one is we can about the clear signal, because of whenever we can store the either 1 or 0 in first clock pulse. So whenever goes into the second clock pulse, so first one we can clear about this bit, right? And we can add the next bit. So we can give on to the clear command. This is the clear command. So this is the clear command. And now input D 0. First one is D0, second one D1, D2 and D3. Right? So this is the input of each and every flip-flops. And now dear students, we know about that. We can give one to that. First one is D0, that can be shifted toward the D1 in next clock pulse. Similar way that D1 goes into the D2. So output is Q0 and this is the Q0 bar. This is the Q1 and Q1 bar. So that Q1 is shifted to the input of D2, and now this is the Q2 and this is the Q2 bar. That Q2 is shifted to the D3, and now output of D3, this is the Q3 and Q3 bar. So D3 is again that is given to that input of D1, right? So dear students, now we can clear about that, how that ring counter can be work. So again consider with the first clock pulse, right? First case that is Q0 is 1 0 0. So initially we can applying this one is 1, remaining all are the 0, right? So as per the characteristic of D flip-flop, the input is D is 1, at the time output is 1, and 0 at the time output is 0. So this we are getting the Q0 is 1, here 0, so you are getting the 0, here 0, here you are getting the also 0, and here is 0, right? Now that 1 is shifted to here whenever that second clock pulse will become, right? So and this 0 is come to here, this 0 is come to here, and this 0 is come to again here, right? So in second clock pulse, the only one input are 1, this is the D1, so we are getting the Q1 is 1, the rest of the are 0. In second input, second clock pulse, this is the D2 is 1, third clock pulse D3 is 1. So similar process is continuously. So this is the applications of the ring counter. Now dear students, for this counter we are considering the first clock pulse. What is the output after the first clock pulse? We are getting the output is, that output is in terms of the Q3, Q2, Q1 and Q0. So this is the 0 0 1. The second clock pulse, this output is Again, that can be shifted towards the 1 bits. So this is the 0 0 1 0. Third clock pulse, this is the output is 0 1 0 0. Fourth clock pulse, this is the output equal to 1 0 0. Fifth clock pulse, this is the output is like that. Again, this is the similar to the 1 1 1. So this is the logic of the ring counter, right, dear students? So now we can designing the Johnson counter, otherwise twisted ring counter. The second applications of the shift registers. Johnson counter. Otherwise it is also known as a twisted ring counter. Twisted ring counter. Johnson counter or a twisted ring counter. So that now we can designing the what is the logic, how we design the Johnson counter. That logic is similar to the ring counter, but only one difference are there. So this is the logic of the ring counter. So last bit that can be goes into the first bit. Now in this case of the Johnson counter, the complement of last bit that can be goes enter into the input of the first bit. This is the major difference between ring counter and Johnson counter. Here the similar bit can be goes into the first flip-flops, but now in case of the Johnson counter, the complement of last bit that can be goes to the input of the first flip-flops. So now we designing the again logics of the Johnson counter. Now this is the condition of clock pulse. Now clock signal, output Q0, Q1, Q2 and Q3, right? And now this is the complements of last bit, so this is the Q3 bar. So whenever the first clock pulse will become, and we can designing with the positive level triggering. So initially that goes 1 0 0, and the now complements of this was 0 is 1, correct? So whenever the second clock pulse will becomes 1, so this 1 can be shifted here, that 0 can be shifted here, that 0 can be shifted here, and this 0, but the complements of 0 is 1, and that 1 can be shifted here, right? And now third clock pulse, again clock signal is 1, that 1 is shifted to here, that 1 is shifted to here, that 0 is shifted to here, and this 0, the complement of 0 is again 1, that can be shifted to here, right? And this 0, the complement of 0 is 1. Now next fourth clock pulse, that 1 is here, that 1 is here, that 1 is here, and that 0 complement of 0 is 1, and 1 is shifted to here, right? Now fifth clock pulse, again that 1 is shifted to here, this 1 is shifted to here, this 1 is shifted, and 1, the complement of 1 is 0, and that can be shifted to here. Now the sixth clock pulse, again 1, that 0, that 1, this 1, and the complement of 1 is again 0, so that can be shifted to here. Seventh clock pulse, so 0 is shifted, 0 is shifted, this 1, and the 1, the complement of 1 is again 0. Then 8th clock pulse, this 0 is here, that 0 is here, that 0, and 1 is complete, complement of 1 is 0. And 9th clock pulse, this 0, this 0, this 0, and 0, the complement of 1 is again 1, right? So that first clock pulse and fifth clock pulse, 9th clock pulse will be equal in case of the Johnson counter. The second clock pulse and 10th clock pulse will be equal to the Johnson counter. So now dear students, we can designing the Johnson counter by using this logic. So that here we can utilize the 4 bits to store to design this counter. So we can utilize the 4 clock pulse and 4 flip-flops. So this is the first flip-flops. This is the second flip-flops, third flip-flop, and fourth flip-flops. Right? So this is the 4 flip-flops. So again we can applying the clock pulse to each and every flip-flops. This is the D0, Q0, Q0 bar, D1, Q1, Q1 bar, D2, Q2, Q2 bar, D3, Q3 and Q3 bar. Right? So this is the clock signal. So now this is the clock signal. And now we can given the clear command to each and every flip-flops. So this is the applying the clear command each and every flip-flops. Now output of first flip-flop that can be goes to the input of second. Output of second flip-flop that can be goes to the input of third. Output of third flip-flop that can be goes into the input of the fourth, and the output of fourth flip-flop, the complement output of fourth flip-flop, that can be given to the input of first flip-flops. Right? In case of the ring counter, we are counting the input of last flip-flop that can be given to the input of first flip-flops. But in here, we can utilize the complements output of last flip-flop that can be given to the input of first flip-flops. Right? So this is the logics, and now we can designing this logic with this output. So what is the output of first clock pulse signal? This output, consider the Q3, Q2, Q1 and Q0. So this is the one output can be considered to that Q0, 0, 0, 0, 1. The second clock pulse, that is the 0, 0, 1, 1. Then similar way 0, 1, 1, 1, 1, 1, 1, 1, then 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0 and the 0, 0. This is the output of each and every next clock pulse in case of the Johnson counter. So dear students, now we can clear about that what is the major difference between ring counter and Johnson counter, and both the application of the shift register. So this is the logic diagram compared to the both Johnson counter and ring counter. So here we can utilize the output of last flip-flops Q3 that may be considered the input of first flip-flop, and in case of the Johnson counter we are counting the complements output of last flip-flops that can be given to that input of the first flip-flops. And due to this change we are considering the clock pulse of ring counter, first and fifth clock pulse both are the same, but in case of the second and sixth clock pulse are same, third and seventh clock pulse are same. That means after every fourth clock pulse we are getting the repeater clock signals in case of the ring counter, and in case of the Johnson counter that can be occurred after 8 clock pulse. That means the first and 9 clock pulse both are the same, the second and 10 clock pulse are the same, third and 11 clock pulse are same, fourth and 12 clockwise outputs are same. So this is the major difference to designing the ring counter and Johnson counter.